So we're asked to write a few algorithms for several sorts. One of them is a bubble sort, an insertion sort, and lastly our wildcard sort, which we chose to do selection sort. Our bubble sort is a simple sorting algorithm, and it compares its adjacent items and swaps them. Then it repeats through the list or the array until there are no swaps needed. So here's an example of how a bubble sort would take place. A set of integers are placed into an array, 7, 3, 6, 4, and 10, and they are unsorted. And here the first two numbers, 7 and 3, are being looked at, 3 being the minimum of the two numbers, so it gets swapped. It moves on to the next line, 7 and 6, because 6 is smaller, they get swapped. Then 7 and 4, same thing happens, swapped between those two integers. And then 7 and 10, no swap takes place here because the 10 is much larger than the 7. Now the array is still not in a sorted list, so it would have to go through a second pass in order for the sort to be completed. The 3 and the 6 will be again looked at. Because the 6 is much larger, there will be no swap. The 6 and the 4 will be swapped. And then the 6 and 7 looked at, no swap taking place. And lastly, the 7 and the 10. And here in our program, you can see where we've written out this loop, our setup for the bubble sort. Where here in the register we'll get the first element and then get the second element, and we'll take a look if the second element is less than the previous element, and if it is, then they will swap, and we'll move into the swap loop, which we have down here, and it gets stored. Basically it gets stored in the second element, and the first gets stored in this second element. Second gets stored in the first element. Sorry, excuse me. Alright, so our next sort is the insertion sort. It's very simple, efficient for small data. It's actually more efficient than the bubble sort, and it's very stable. And an example of this, if we have 3, 7, 4, 9, 5, 2, 6, 1. What takes place is actually it takes the integer and checks it with the integer next to it to find if it's much smaller or larger than the other. So here in the first line, 3 is being considered against number 7. Because 3 is smaller, it stays in place. Now 7 is being considered because 7 is much larger than 3, and then it will just stay into its place. In the next integer, because 4 is less than the 9 and then much less than the 7, it gets moved into where it needs to go. So it gets checked between the integer to the left and also the integer to the right. The same goes for each line. It starts to take place. Here the 9. The 9 stays in its place because it's much larger. Then the 5 into consideration. It gets moved past the 9, past the 7, and in between the 4 and 7. Then the 2 gets checked against every single digit that was placed in before. The 6 move in between the 5 and the 7, and lastly the 1 being considered, placed all the way at the front. And here we can see in our insertion sort where our setup is. It basically uses a loop. There's our insert shift. Basically, when you go through this loop, there is that. Checking element if it's larger than the current element, yeah, using this SLT. Okay, and our last sort is the wildcard sort, which we've chose to do selection. Technically, it is an inefficient sort because of the way it has to compute. It is performed worse than the insertion sort that we just went through. It basically splits the array into two, sorted and unsorted. It finds the smallest number and stores it into the sorted list. Or it could be vice versa. You could find the biggest number and store it into the new list. So here's an example of a couple of integers or several integers that we put into an array: 74, 35, 22, 32, 21. And what this array, what our loop is doing is checking to see which one of these numbers or which one of these integers are the minimum. And obviously this one is 21, and it would set the new minimum is 21. Then it goes through the list again with the set minimum at 21. So the next number it would find would be the 22. And it would again set 22 as the minimum. So as it goes on, it will find the next line, next number, 32, then onto 35, and then lastly onto 74. And here in our selection sort, you can see that we've created the loops to go through the array, find our minimum, then set our minimum, and then swapping values. And in a few seconds or a few minutes there, Victor's going to show an example of how our algorithms run. Thank you.
Okay, so I'm kind of looking back at scoring I did because I have to make some separate for this to work. But I think we are going to look at bubble sort here. And let's see. Oh, so right there. If there's one element in the list, I just kind of go to done because there's no need to sort. You can see there's some setup going on there. I guess I'm going to show my little screenshots here from my textbook. SCR 222. We're going over sorting too. So let's go. This is from my textbook. So this one's for bubble sort, and it's just showing what I'm pointing at there is it's swapping each element and just going down the line. 6 and 9 gets swapped, 8 and 9, 9 and 12 doesn't. So you can see that that's pretty much what my loop is doing. You can see it's getting the first element, second element. If the second element is less than the first, it swaps. There's that swap function, and it's just really just moving things around, and it increments the outer loop there, n minus 1 times. We're going to jump over to insertion sort. Same deal at the top. One element, we don't worry about it. We'll just jump to done, no sort. You'll see I'm swapping the first element there. It's part of how the algorithm goes. Let's see, outer loop, it ends. I'm kind of fast here. Swap first and swaps the first 2 elements, and it's going to shift Okay, excellent. So I'm bringing this up. So you swap the first two elements, and then you kind of shift right when you insert later on. See, 1 gets inserted and 369 gets shifted. See, you kind of notice right here. This is what I do. I kind of shift 9 and 1. Then when I get to the 3, I do one more shift. So see what's going on here. That was that one. Okay, wildcard. And the wildcard selection sort is pretty much what you think of when you think of any kind of sorting. It's pretty much start at the front of the list, find the smallest one on the list, and swap them. Move down, find the next smallest, swap them. So doing sublist. So if you look at this one, let's see, find min. Yeah, find min is really what is going to run this one. So that's pretty much all there is to these. Thanks for watching.